Okay, here we are back in Math 1. We're doing our exercises today, so it's our first solve by graphing one. We're doing the homework today. So just looking at the homework in case you need help with it. Okay, and so there we are. We did, in the lesson, we did some samples. We're going to do some more. And remember what we want to do here is we want to just set up a table and say f and x of x, f of x, f of x, or y, right? You can say the y value, what comes out when I do this transformation. And so as always, you want to start with 0 and you say, well, if I put in a 0, I get out a 4. If I put in a 1, I get out a 1 minus 5 minus 4, I get out a 0. And if I put in a 2, I get a 4 minus 10 minus 6 plus 4 minus 2. If I put in a 3, I get 9 minus 15 minus 6 plus 4, also a minus 2. Okay, so that's interesting. And if I put in a 4, if you look at this, what do you expect to get out if you get out a 4? Hopefully after a while, you'll look at this and say, oh, if I put in a 4, I should get out a 0. Let's see if that's true. Okay, so 4 is 16 minus 20 is minus 4 plus 4 is also 0. And finally, you say, well, and if I put in a 5, I expect to get 4, okay, for the symmetry of it. So when you look at that, you see how you're symmetrical around 2.5. So 2 and 3 are the same, 1 and 4 are the same. We think 0 and 5 are going to give us the same output. So input and output x, and output is y, or f of x, same thing. So 5 squared, 25, minus 25 plus 4. Okay. And so then we plot these and we say 0, 4. So there's where we go through the y-axis, is when x is 0, we go through at 4. We have 1, 0. We have 2, minus 2, and 3, minus 2. And then you see it starts coming around, 4, 0, and 5, 4. You can see the symmetry of it. And where, in fact, do we go through the, so it's between, so between 2 and 3. So you see this line here. Okay, so the graph's going to be symmetric on both sides of that line. Okay, so we've got that. And so we don't know exactly, we know that the value is going to be at a minimum for x equals 5 halves. 5 halves, y equals, so how would you figure that out? That's something for you to think about. How would you figure that out? Okay, what are our zeros? Okay, so the zeros, that's a short way of saying what is the value of x when y is 0 for this quadratic. And we see that we have for x equals 1 or x equals 4. What's the y-intercept? So the y-intercept, where does it go through y? Well, that's an easy one. You just say if I put in no x, so 0 squared minus 5 times 0, 0, minus 0 plus 4, I get 4. So it's 4. Okay, let's look at the next one. It's a little bit different. And it's different because you'll recognize it as a binomial that's getting squared. And so we'll say, okay, here we have x, and then f of x is x squared minus 4x plus 4, or you could just say y. What is y if I put x into x squared minus 4x plus 4? As always, we'll start with our trusty 0, and when we put a 0 in, we get a 4 out. Okay, when we put a 1 in, we get 1 minus 4, so minus 3 plus 4 is 1. When we put 2 in, what do we get? We get 2 times 2 is 4. Okay. Minus 4 times 2 is minus 8. So 4 minus 8, minus 4 plus 4 is 0. So there we go. We got 0. And then 3. So what are we going to get for 3? 3 is 9 minus 12. Minus 3 plus 4 is 1. And you look at that and say, oh, look at, there's a symmetry. So 1 and 3 both give me the same value of output, a 1. So I think 0 and 4 should give me the same output. So I put in a 4, and I'm expecting to get a 4 out. So it's 4 times 4, 16, minus 4 times 4, minus 16, 16 minus 16, 0 plus 4, 4. And look at that. I see I've got this symmetry. So I say 0, 4, 1, 1, 2, 0, 3, 1, 4, 4. All right. And so there you see that line of symmetry goes right down middle of the graph and through the point 2, 0. Okay. So in this case, are the zeros positive? Well, there's just one zero, right? There's just one zero, which is 2, 0. So in other words, 2 is the zero, the only zero for this equation. Why is it different? Well, if you think about it, right, this is really x minus 2 quantity squared. So when does that equal 0? When x equals 2. Okay, so we have another one that's not going to work out quite so well. So we're going to look at it and see what we get. So we say, if we put in x, and f of x is x squared plus 3x minus 4. So we put in 0, we're going to get out minus 4. See how that one's an easy one to get because it's only the constant that's going to matter when x is 0. Okay, so let's just try again. So we put in a 1. So we get 1 plus 3 is 4. So that's going to be 4 minus 4 is 0. Let's see what happens with 2. So we put in 2, and so now we say, it's going to increase, right? So we've got 4 plus 6, 10 minus 4 is 6. Okay, so if you look at that, you can say, well, I've got an x squared and a plus, so it's going to keep increasing. So I'm going to want to look on the minus side now to get more ideas about where the graph is going. So I do minus 1, and maybe I get 0 there. So I say minus 1, so is going to be plus 1 if I square minus 1. So plus 1, okay, minus 3, minus 4. Oh, no, that's going to be actually, so it's going to be 1 minus 7, so minus 6. Okay. So 0 is minus 1 is minus 6. Well, let's see what else we got here. Okay, so let's try minus 2. So put in a minus 2, and we're going to get 4. So 4 plus minus 4 minus 6 minus, it's going to be also minus 6. So that might be where we found it, right? Is that, so now as you get more negative, the square is going to overcome the regular x. And we're going to see that with minus 3. So if you think about what's happening, right, is that you have a negative number, but its square is positive. So now you have minus 3 squared is 9. 3 times minus 3 is minus 9. So they cancel out, and you get minus 4. And now you see the symmetry. So it took us a little bit of time to find it, okay, but we found that 0 and minus 3 both lead to minus 4. So that's going to give us our symmetry. So let's draw that in first. So we have 0 is at minus 4. 0 is at minus 4. And minus 3 is at minus 4. Okay. And let's see what other points we have. So we have 1 is at 0. 1 is a 0. So now you see, with the symmetry, I'm going to be able to find out where that other 0 is. 2 goes all the way up to 6. 2 goes all the way up to 6. Okay. And where is, and minus 2 is all the way down to minus 6. Okay, so we've got, and minus 1 was also minus 6. Okay, so now you see, there was where the bottom of it is. And now can you predict where the other 0 is? Well, you kind of can, right? As you say that the middle is going to be right here at minus 3/2. Okay? And so I'm over 2.5, so it's going to be, looks like at minus 4. And if we try that out, let's try it out. So minus 4. So minus 4 times minus 4 is 16. So 16 plus 3 times minus 4. 16 plus minus 12 is 4. Minus 4 is 0. And there it is, right? So we've got another symmetry there. And we said, all right, I'll put that in. So minus 4 is our other 0. And now where is our value going to be the least? And when you look at that, you can see the symmetry around x equals minus 3/2, x equals minus 1.5. And so you know that the value, the minimum value is going to be when x, it's going to be when x equals minus 3/2. And you could calculate that by plugging that value in. Okay? And that's what we're going to do. We're going to learn to do that, right? Is to say, okay, whatever this, we're going to find out what comes out when we put in minus 3/2. That's the minimum value. And so if you drew this, let's say go through there. And where was our y-intercept? So our y-intercept was at minus 4. That was our y-intercept. Okay, so let's go. So we've got this, and then we've got our graph, and we'll be done with your exercises. Although there's another exercise to do based on box and whisker plot. Okay, so let's do the same thing. We'll set up our chart. And so x, y. What's the y, or what's another way of saying it is what's the f of x? What's the output? So, or you could say the input. What do I put in and what comes out? Another way of looking at it. So as always, we start with our 0. And we say if we put in 0, we get minus 5. Okay, because all you care about then is the constant when you put in 0 for x. And we always, usually we'll start with 1 after that. So we say 1 plus 2. So 3 minus 5 is minus 2. And we know that we're going to increase in value because we have x squared and positive 2x. So we say 4 plus 4 is 8, minus 5 is 3. So we're going up. So you can see you're going up that way. And so now you say, well, I better find out what happens on the other side. So on the other side, I look and I say, well, I've got minus 1. So minus 1 times minus 1 is 1. 1 minus 2 minus 5. So 1 minus 7 is minus 6, I believe, looking at that one, right? So I have minus 2 minus 5 minus 7 plus 1 minus 6. All right, so what happens when we do minus 2? So minus 2, now we should get a bigger, right? So now the x squared and the 2x are going to cancel out when you put in minus 2. So you get minus 2 times minus 2 is 4. 2 minus 2 is minus 4, so those cancel out, and you get minus 5. Okay? And so, although it wasn't looking good, okay, we say, oh, there we go. So we've got this symmetry. So we get the same value for 0 and minus 2. And so now I say, oh, I think what we found is that the graph goes around minus 1 is where it's symmetric. And so let's plot what we've got and see if we need to do any more. So when x is 0, y is minus 5. When x is 1, it's minus 2. Okay? And when it's 2, it's 3. Okay? So you see now we're not going to have a whole number when we cross the x-axis. Okay? Minus 1 is minus 6. And minus 2 is minus 5. And so we appear to have found the bottom point. Now, what do you think is going to be the value of minus 3? So it looks like it'll be symmetric. It'll be the same as the value of 1. So let's put that in. So minus 3 will be 9 minus 6. 9 minus 6 is positive 3. 3 minus 5 is minus 2. Okay? And so it's what you expected. So you see that symmetry there that we've got. Okay? And so then what do you expect to get for minus 4? So for minus 4, we expect to get the same thing that we got for 2. So we're expecting a value there. Okay, so let's draw our line of symmetry. And our line of symmetry is right at x equals minus 1. Okay, so are there any zeros? There are, but you're going to see that we have to just estimate them, okay, because we go through the x-axis somewhere between, so x equals approximately equal, so we'll say approximately equal to 3 halves, or it's approximately equal to minus 7 halves. Okay. So we had to just estimate. Okay, so the graphing doesn't always give us the precise answer we're looking for. But what's the minimum value? And so our graph did give us that. So it looks like when we put in -1, we get out -6, and that's the minimum value. And we also found from graphing that when we put in 0, we get out -5. So that's our y-intercept. Okay, so next, we're going to use this graph to say, well, what's my x when I have a certain y? And so let's see, what is our graph when, what does x have to be for y equals 2? So to do that, we just say, well, we're going to draw a line through here. So this is y equals 2. And then we'll go down and say, well, what were the x values? Okay, so in other words, if I put in, looks like about a half, I get out 2. Or if I put in 3 3/4, oh, it's a little bit less than a half, so let's say 3/8. Or if I put in, I have to look at the scale here. So if I put in 3 3/4, I also get out 2. Now, what about for 5? And so we say, well, where's 5? So here's 4, here's 5. So if we go across on that line, we say, oh, look, it looks like we get a value that's right on a lattice point. So it looks like we could get -1/2. So we go down and we say, okay, this is -1/2. So -1/2 gives us 5. Or we say from here and we go down and we get, 4.5. So 4.5 also gives us 5. So, okay, so not that you would do that all the time, but it helps to give you a sense of what can you get from the graph, what information can you get.